Problem is, I don't know the problem, so I'll have to bring it down here. Alrighty. Can't copy and paste. It'd be nice if you could. So that'd be 2z over z squared minus 4z plus 4 plus 2 over z squared plus 4z minus 12. And 2z over z, well, that's a shortcut, z minus 2, and you can write it as z minus 2 quantity squared, because that's a shortcut, plus 2 over z, and what is that going to be? That's going to be 6 and 2 and 2 and 6. That'd be a negative 2 and a positive 6. Somebody check that for me.
That's right.
So, what is the rule? What did I told y'all when you have the same base and exponents and you're trying to find the common denominator? What do you do? The lowest or the highest exponent? So what's our highest exponent with the z minus 2? Squared. So that's the common denominator. Z minus 2 quantity squared. And then what? Z plus what?
6.
Z plus 6. Now, I'm going to go to the next page. You go to another page. I'm going to go back to pre-algebra here for a minute because somebody might have the question, well, why isn't it z minus 2 squared times z minus 2 times z plus 6? Well, when you go back to pre-algebra and you go back to the basic rule of the highest exponent, let's say you have x 1 over x squared plus 4 over 3x. What's your common denominator? 3x squared. And you did those all one after the other in pre-algebra or algebra 1. And you didn't question it at all. You always go with the highest exponent. When you go with the highest exponent, it takes this one and it also encompasses what? The lower exponent. So that's why you don't do all three of them, because this one takes care of this one and this one. Okay? So how many times will this go into this?
3 plus 6.
So that's 2z times z plus 6. And how many times will this go into this? One of these and this. How many times?
Z minus 2.
So 2 times z minus 2. Okay, now clean up the top. Distribute, clean it up. Put it over one denominator.
It's okay if you write the whole denominator out.
You can if you want to. That's fine. Z minus 2 quantity squared times z plus 6. And then up top, we have 2z squared plus 12z plus 2z minus what?
4.
Okay, now we're going to go to the next page. I'm going to let y'all make sure you got to that. I'm going to go to the next page and copy it over and finish it. So so it won't be as cumbersome, mushed up on the page. If it'll let me copy it. But usually with the white paper, it lets me copy. Just do it the easy way. Okay. So 2z squared plus 14z minus what? Over z minus 2, quantity squared, times z plus 6. Factor out of 2. That's factorable. So it's either one of these answers.
So you could have stopped it at 2z squared plus 14z.
The reason I did this was because I wanted to see if this was factorable and maybe we could cancel one of these out.
So I would have gotten it right if I kept the first.
Either one of those. Now, I'd like to go into 6.5 a little bit, just so y'all can have something to chew on over the weekend. And let me also go back to the question so y'all can see what the answer, see what form they put it in. First one. Oh, well. I don't know what happened. I don't know which number that was. Do y'all know?
10 or 11.
Number 10, 11? Is that the same one?
Yeah.
I don't know. Oh, I hit save. That's what. Okay, so we got it right. I'll take either answer. And it probably will also, but I don't know. All right, I want to move into 6.5 because 6.5 is basically building on top of 6.4. Let me just go to 6.4 or 6.5. In fact, I think it is. Hold on, let me check and see. It should be equations. Rational equations. Complex rational expressions. Okay, we're still in expressions. Okay, but I want to move into this, but this is not a big deal. They look all funky, but it's not hard. And I'll show you why. Let me just get to some problems and let's pull up a problem. Well, let's do one of the examples. I like this one. All right, write that problem down right there. This is pretty. The reason I picked this one is because it's kind of simple. It's got some simple denominators. I don't want you to see all that other stuff. All right, there it is. Write that one down. This is your first example of a complex rational expression. What's a complex rational? A difficult fraction. And it's not a big deal. If you make everything a fraction, it's not a big deal. But see, what happens is people just go into it. They don't explain. The first thing you do on this problem is make everything a fraction. Well, you have fractions up here, Hubert. Well, what are you going to do with this one? Put it over what? 1. That's your first thing you do. I can't write because it's so big. Hurry up and write it down. And then we'll do it. Let me write it over here and then I'll bring it back down. X squared minus 5 y x xz there. All right. And I teach and I tell students, whether they're in math 120 or math 110 or math 140, I always tell students, if you're one of these students that has to start from the basics when you do a problem, there's nothing wrong with that. Make it a fraction. Build on it. You can cut it out when you need to cut it out, but don't cut it out if you're not confident with the problem. So, x squared over y minus 5 over x over xz over 1. How many denominators do we have there? 3. Get a common denominator. You got it? What is it? xy. So you're going to multiply. I'm going to put this in red. You're going to multiply by xy over 1 over xy over 1.
So you wouldn't put xz, denominator, under 1.
I'm sorry.
So
Under
you
1.
put the 1 under the xz on the denominator?
Uh-huh.
So you were thinking, I thought the xz were real numbers, so therefore it would be
All real numbers are over 1.
over 1.
That's why I put it over 1. Now I want you to multiply this through here and this through here. See what happens. Most of you will be able to go through and do it now that you know what to do. But this is the part that people don't know what to do, right here. And I don't show it the way the book does because that confuses students. Some students. I'm going to put a little baby step in here for you. xy over 1. xy over 1. xy over 1. X squared over y minus 5 over x there's your little baby step for you. And now you should be able to use your multiplicative rules of fractions to cancel. What's going to cancel on the first one? That's not rhetorical. Y'all supposed to answer. What cancels right here? Y's. And your fraction is gone. What cancels here? And your fraction is gone. And you really didn't have a fraction here to begin with, so it's a whole number too, or a term. So we rewrite the problem less the complex fractions. So x squared minus what? I'm sorry, x to the third. Sorry. X to the third minus what? Over x squared yz.
Bunch of extra steps, but that's what I got.
Say again?
Said I did a whole bunch of extra steps, but that's what I got.
You went around the world. And actually, you really don't have to use this step. You can do this in your head when you get to doing about 500 or 600 problems. You can go from here to here. And that's how you do a complex rational. Now, they're going to get more challenging. That's a basic Mickey Mouse model. Well, maybe a step above Mickey Mouse.
Okay, and then the x cubed and x squared couldn't cancel out, so married.
Exactly. The only thing that you could do here is if these were two x's, you could factor out an x and you could cancel out an x with one of these. One of those x's right there. But you have to get multiplication in there. And multiplication would be, you know, if we had x cubed minus 5x over x squared yz, there's no multiplication up here. It's all subtraction. So we have to, in order to cancel something, there has to be some multiplication. So I'm going to factor out an x, and you get x squared minus 5 over x squared y squared. Is there any multiplication up here? Yes, right here. So you can take one of those out there.
But with it being just like that.
There's nothing you can do with this. Nothing. You can't even factor anything out. You're done. You're done. All right, let's do nerd. We'll do a couple of more examples and then we'll move into the book homework and see what they got for us to do. All right, that's a test question right there. No yawning in class. All right, do that one. We'll step up from what we just did. Got one more set of so one more term in there. Person sent me not one reminder but two reminders that they're not going to be in class today. All right, you got it written down? So 1 over 1 minus 1 over x.
You have a work email.
Over 1 over 1 minus 1 over x squared. So we have 4 denominators, and what is the common denominator? So it's going to be x squared over 1 over x squared over 1.
So you want to just times it by
You wouldn't
x?
multiply it?
Hmm?
How come you didn't multiply it?
Multiply what?
But like the previous problem, you multiplied the common denominator by all the terms.
That's what we're fixing to do.
Oh,
I'm just setting it up.
Oh, why-
Give me a second.
I'm sorry.
Why wouldn't you do it just by x? Why would you got it?
What's the common denominator of all 4 denominators?
I just messed up.
All right, so I'm going to put in a baby step for you. X squared over 1, x squared over 1, x squared over 1, x squared over 1. And then I'm going to multiply it through with each term. I'm sorry, 1 over 1 minus 1 over x. There you go. And let's see what happens. Well, when you take x squared times 1 over 1, what do you get? And what happens to these two x's right here? What happens? This cancels with this x and leaves what? X times 1, which is, what do you got here? X squared, Hubert. That's right, class. And what do you have here? Either I've done something wrong, or we have 1 as the answer.
That's not
I must have done something wrong.
I got X. That's what I got.
You got what?
X.
Well, then I must have done something wrong. Let's see what the answer is. What did I do wrong? Did I copy it down wrong? Oh, 1 over x squared. Hold on. Did I have 1 over x squared? The x cancels. The x squareds cancel right here. This right here. That should be an x squared, shouldn't it? There. That's what it is. Okay. Sorry. All right. Let me go back. My bad. Okay. Do I have this written down right? 1 over x. Is that right? And then 1 over 1 minus 1 over x squared. Is that right? Looks right. I'm looking to make sure. Okay. So that'd be x squared minus x, right? Over x squared minus what? 1. And that's shortcut number what? 3, Hubert. That's right, class. And what happens? X minus 1's cancel. And you're left with x over x plus 1. So it kind of pays to write down the problem down correctly.
If you have x over x limits just the other one,
Yeah.
then how come, whenever we had it on top, it was like x squared over 1 minus x squared over x. Why wouldn't that just be like x squared over 1 minus 1?
Okay, I'm not following the question. Are you talking about the original problem? Right here?
like when you multiply it, and then, you know, you did the x squared over 1, and then on the bottom we did x squared over 1,
Mhm.
multiply it,
Mm-hmm.
and then when you multiply the 1 over 1, you got x squared over 1 minus, on the top, then you got x squared over
X.
x. Why wouldn't it just be like, when you cancel out the x's, it would just be x over x?
X squared over X cancels X over 1. When you cancel, this X right here cancels one of these out. This one cancels out. See, this is X to the first power. What's X squared over X to the first power? Well, 2 minus 1 is 1.
Oh, so the x squared is still.
Yeah, it's still here. You just cancel it and it becomes X to the first power.
See, I was going ahead and doing the x squared times 1, which is x squared, and putting it over the x.
But that would work, but you still got to cancel it out. Because you have X squared over 1, X squared over X.
I'll show you that.
Have a good weekend.
Bye.
Bye.
I thought it automatically did that. When you multiplied it, I thought it was just x squared, and that went over x.
Well, it is, but now you got to cancel that out.
And so that's why I was like, well, that should
Yeah.
just be 1.
Now, well, one of them is X over X is 1, and then that leaves X to the first. So you were halfway right. All right, let's move on to a more challenging problem. Yeah, y'all need to be challenged a little bit. Let's see. Yeah, I think number 42 looks good right now. 42. I'll blow it up for you. -42. 1 over x plus h minus 1 over x over h over 1. And I'm going ahead and putting it over 1 when I write it down, so that therefore I'm already concentrating on the common denominator. Give y'all a couple of minutes. See what all these emails are about. See if I'm fired. I may have to teach at Westside next semester. No, just another reminder, I will not be in class today. Okay.
So would you do x plus h as a common?
The common denominator would be x times x plus h.
It would be like x squared plus h.
It'd be x squared plus x h if you wanted to do it that way.
X squared plus
I mean, I would just leave it x times x plus h.
Oh, so you have to do the old denominator.
Yeah.
Not just the
No.
little.
All three denominators. You got three denominators there. X plus h, x, and 1. Now we could make it a little bit more challenging and put something under that h if you want to. This is what I like about this. I can actually pause this. Number 45. And I'm going to freeze that screen because I need to put the solution for the last problem on the board for the people at home. If I can find it. There it is. There's the problem for the one we just did. Remember, what was that, 42? The problem we just did, wasn't it 42?
Yeah.
Well, there's a solution to 42. Hit pause and you can write it down. I'll leave that on the board and let y'all, I'm going to give y'all, let's see, right now it's 11:34. I'm going to give you 6 minutes to work on it.
So is that what you do? To get them all the same? You just multiply all those and
What's the rule when you got same basis and exponents? What do you use? The higher or the lowest exponent?
so you just multiply
That's it.
all
A cubed, B
those?
cubed.
So you just do like those two
Mm-hmm.
by the top.
A cubed, B cubed. That's it.
Alright.
Might be showing you a different world, but
Do you want us to factor this into that?
You can.
Because you end up with this long thing, and you can't cancel because these are adding.
I don't think that's it. I don't think you have to.
Basically, when I do it, I take the first and then get common denominators for the first one and go ahead and add it, and then do the bottom one, and then multiply by the reciprocal.
Okay, you can do that. That's fine.
Okay.
That's fine.
Okay.
A plus B. Yeah. I don't think you're gonna get anything out of that.
You won't.
That ain't what I want to watch. No, I was gonna show you something, but
Just situationally, not like because of
there it is.
the situation. It's supposed to be calm in the classroom, and then
Yeah.
Benny Hill starts playing.
Yep.
Looking for the guy who's chasing him.
And what happens with the first term? It makes this what? So let's clean everything up.
This is right.
So this is a squared b cubed plus a cubed b squared over b cubed plus what?
A squared. I mean, A cubed.
Okay, keep going. What do you mean keep going? Keep going. You may be able to cancel something out. I don't know. Is there anything you can do at the top?
Cancel out the big cube.
Factor out a common term. You can factor out a common term on the top. What can you do on the bottom? Shortcut number
Cubed, so
4. Now, I don't know. I don't know. You may not have to. I'm just, why am I taking it one more step? To see if I can what? See if I can cancel anything. So, factor out a common term here, and let's see what happens. I'm going to factor out an a squared b squared. And what will that leave me?
would be B cubed, I'm sorry, B
b plus
plus
a. And then what is this? Shortcut number 4, Hubert. That's right, class. B plus A times B squared plus BA plus A squared. I'm sorry, minus. That'd be a minus. Sorry. Sorry. And what happens here?
cancel out the B plus A.
Good job. And your final answer is a squared b squared over b squared minus ba or ab plus a squared.
I didn't
How
get
come
that
you
either.
wouldn't, how come you wouldn't cancel out the B squared in your final answer?
Because these are what?
Those are married.
These are married on the bottom. You can't unless you factor something out.
I would have done it, and I was just 1 over negative BA.
Can't do that.
Yeah, I didn't get that.
And something else, if something seems to be too simple, guess what?
It's fine.
Usually that's true. It's not. It's not that easy.
Very good, nice.
No, you're learning. If you knew the material, you wouldn't be in here.
No, I was like, I got this is A minus B as the final answer. Yeah, no.
No, well, no.
So how,
Huh?
I just don't, like, I understand where you got a squared plus b squared, but I don't understand where you got a squared b cubed plus a cubed b squared.
I don't know where you're at. Tell me
Top,
where.
right.
Right here?
Mm-hmm.
You don't know where I got this.
No.
Okay. Do you see this? That cancels with that a cubed, makes it a squared. Do you see that? B cancels with this and makes that b squared. So you got a squared b cubed plus a cubed b squared. And that's at the top.
Now, how is your common denominator b? Or a and b? Like,
Common denominator is not ab. Common denominator is ab cubed, b cubed. There's where I'm multiplying by ab cubed right there. A cubed, b cubed. And then I'm canceling. You should not have a denominator after this right here. I mean, you'll have a denominator, but each of your terms are whole. You do not have no more denominators in the individual terms.
a squared and b squared.
Did you get a common denominator on the top and then the bottom separately?
Yeah.
Okay, well, I'll do that for you on the board over here. Hold on. Don't have a black marker. Blue. Have to do. One over A plus 1 over B.
Okay, can we just like go ahead and get a common denominator for that? Just that part?
Yeah, be AB.
Right.
So it'd be AB over 1 and multiply that through. But you got to multiply the top and the bottom by AB.
So you're going ahead and taking it and flipping it to the reciprocal and just multiplying it?
No. No. What I'm doing is, see, if you, I think the problem you're going to have, let me write the whole problem down. 1 over A cubed plus 1 over B cubed. All right, if you get the common denominator for the top, you have to multiply the bottom by that also.
Right.
Okay, are you doing that?
Yes.
Okay, so you're multiplying by AB over 1 right there. Okay, is that what you're doing? All right, so let's do that. So that's going to be AB over A plus AB over B over AB over A cubed plus AB over B cubed. And then
Okay, but then you
that
don't
cancels.
have common denominator.
Well, you're going to take these out, and then you're going to have to do it down here, but you're going to end up with looping yourself around, and you're going to get another denominator up here.
That's not what I did though.
Well, tell me what you did.
I multiplied the first one, like 1 over A times B to get AB on the bottom. So I had B over AB plus 1, and then I had A over AB.
What did you multiply by?
I did both of them separate, so like I multiplied 1 over A times B and 1 over B times A.
Well, if you do that on the top, you have to do that here.
Okay, so you can't like solve the top and then
No.
solve the bottom and then put them
No,
together?
you can't do that.
Okay, because that's what I've been doing.
You can if you multiply through on the top and the bottom. Remember, you're multiplying this by a factor of what? What is this? 1. This is 1. You're multiplying the numerator, but you're not doing the denominator. And you can't do that. Period. I thought you were multiplying through by the common denominator on the top and then the bottom.
I was doing like on the first one, I would have A over AB, or I had B over AB plus A over AB. And then I added those and had A plus B over AB.
Well, like I said, I don't know if you can do that and not do it on the bottom because you're not multiplying through by a factor of 1. I'll have to look at it with you after class. I'll be glad to. I'm just trying to look and see. I think it would work if you did. Okay, hold on just a minute. Let me see if now I did it the legal way. Okay, I'm not saying I got to look at yours and see what you're doing. This is A squared, and this will be B right there. So I get B over 1 plus A over 1 over B over A squared plus A over b. So now I need to multiply by a squared b over 1 over a squared b over 1. And that's going to leave me with a squared b squared plus a cubed b. And that's going to cancel. And that's going to cancel. And that's going to leave me with b plus a over b squared plus a cubed. I think I should have another b cubed in there somewhere. I think I messed up on my b cubed. It should be a b squared probably, because that fits. Is mine 1 over a squared? See, I'm not coming out with the right answer doing it that way. So I think we better stick with what we're doing, what I'm doing. I'll look at yours. And plus, you're going around the world getting, it's best to get a common denominator of all 4.
So how can you get a common denominator with a and b when your bottom has a cubed and b cubed?
You go with the highest exponent.
So wouldn't your common denominator be a cubed b cubed?
That's what I did.
Okay.
Right here.
Okay. I'm just gonna rework this.
I think it's best. Now I'll look at yours after class, but I don't know, it seems like to me you're doing double the work.
Yeah.
Yeah. All right, let's try one more, and then I want to move on to one more section. What? You'll be okay. I'm going to spend time with y'all. Y'all be okay. Let's try 53. Oh, let's quit. Let's quit before we get started. Let's talk ourselves into not doing 53. Can we do that? That's hard. I can't do that. That's too many things. I think we should quit. Actually, it's the easier of the ones that I could pick because you do have at least common denominators.
So if the top has got common denominators, you only have to do the bottom?
No, the bottom one's got denominators too. I want you to do the adding and subtracting first. Actually, this problem is not as hard as it looks. After you do 1 or 2 steps, you're going to say, oh, this ain't so hard. Have you ever noticed that a soda can, when you pop the top, it doesn't sound like a beer? I've always wondered why that's so.
You know, you actually think better when you're drinking and doing that.
I don't know. I ain't never tried it. Go ahead and add the numerators because you got a common denominator. Go ahead and do that.
But you have, the top half is subtracting, the bottom half is adding.
Go ahead. You're going to get a fraction on the top and you're going to get a fraction on the bottom. And then you get a common denominator.
I'm still writing it down.
Okay, you're still writing it down.
It really isn't that bad.
It isn't. Miss Zug, what time is class over? 12:20. Okay. stop about halfway through and let's see what everybody got. I need a cameraman. That's what I need. What do y'all think? Yeah, y'all just not gonna talk to me no more. Y'all don't like me anymore.
I'm sorry, what'd you say?
No, forget it. I'm not gonna. I'm gonna do like the old women do. Just forget it. Just forget it.
I said, letting you know.
Y'all don't listen to me. X over x squared plus 3x minus 4 minus 1 over x squared plus 3x minus 4 over x squared plus 6x plus 8 plus 3 over x squared plus 6x plus 8. Alrighty. I'm going to go ahead and go to the next step, which will be to put it together because you've got common denominators. So that's going to be x minus 1 over x squared plus 3x minus 4 over x plus 3 over x squared plus 6x plus 8. Now, what do you do when you divide a fraction by another fraction? Yep. So x minus 1 over x squared plus 3x minus 4 multiplied by x squared plus 6x plus 8 over x plus 3. Now, what do you do when you have trinomials? Factor them. So let's factor them. X minus 1 over, dang old 1 and 4. What's that going to be? A positive 4 and a negative 1 times x, dang old 2 and 4. Now what? Well, we have multiplication, so we can do what? Cross out, cancel, reduce, whatever you want to call it. And looks like to me, this can cancel with this, and this can cancel with this. And what's your final answer? Now, was that difficult?
Yes.
No, it wasn't.
Because I didn't do that.
My question is, if you factor out the two trinomials, you end up with x plus 4 in all of them.
Yep.
And I was wondering-
You could do it that way, but just the long way.
I was wondering why just x plus 4 wouldn't be your
Not that.
common denominator.
No, these are your two denominators. If you're doing it your way, there. So x plus 4 would be your denominator, and x plus 2 and x minus 1. So it'd be x plus 4 squared. No, x plus 4. It'd be x plus 4, x minus 1, x plus 2. That would be your common denominator.
We'll just probably, okay. That was
But-
that's where I got stuck.
But you're working it the longer way doing that. The reason I gave you this problem is so you would maybe here see a flag that says multiply by what? Reciprocal. Yeah, I was hoping you'd see that because that's different. This is different from our other problems. Not here. Right here, it's not different because we have 4 denominators. But you should have seen, doing the problem the first few minutes, you should have seen that these are common. If you already have a common denominator, go ahead and add them and put them over one denominator. Do it down here, and then you've got a fraction over a fraction, which you can multiply by the reciprocal, and then you can start canceling.
That's not a fraction over a fraction?
Where? Yeah,
Did we
but
put
this
that?
is not a common denominator. If this was 1a over 1a, you would have went 2 over a. And then if you can add the fractions, do it. But you can't.
So when you have a common denominator on the top, that's when you can flip the reciprocal and multiply it
No.
across.
When you have a common denominator here and you have a common denominator here, you go ahead and simplify as much as you can. These don't have a common denominator. You got different type problems. Totally
Oh, so they don't
different.
even go together? These problems don't go
No,
together?
they don't. That one, they have 4 denominators, but these are the same and these are the same. These are all what? Different.
Okay.
And you're going to see them in your homework, and you're going to send them to me, and I'm going to go over them. So don't worry. Don't spaz. It's not hard.
Can we be done for today?
No!
We can go home.
No, we're not done for
Need
today.
to take a roll.
Look,
Not yet. It's 12:10. We've got 10 minutes, haven't we?
Yeah, but last class you said,
I know.
remind me to take
What?
okay, because I have no idea. Like, every single one of them getting different answers. And so, I did that. I did the x minus 1, and did the top. And then I did the bottom. But then when I came down here, I just factored the bottoms.
Okay.
So then, I multiplied them by what they don't have.
No.
And I did it.
The common denominator is x plus 4, x minus 2, x plus 2. If what you have is here, you got to have 3 denominators out here because you got 1 that's in common and 2 that are not. So you got to have 3 of them out here.
Okay. Because I was like, it's already got, on this one, I was like, it's already got an x plus 4, so that's why I did it.
That's fine, but it doesn't have it doesn't have this. It doesn't have an x plus 2. So you got to have the x plus 2 in there. Right here, you got to have x plus 2, x minus 2, and then whatever that is right there, x minus 2. You got to have that one there, and then you got to have the same thing over 1, same thing over 1, and then multiply through. It's got to have the common denominator. You got to have all of them in there.
Okay. Because then, I got as the finishing answer, I got the x plus 3, but then I was like,
Yeah.
I was going to finish out with it only being x plus 3.
So that's why you're missing one.
But other than that, when I was up here,
Uh-huh.
if I just did exactly the same to top and bottom, wouldn't have got me the answer.
Yeah, it would have got the answer if you'd have put that one in there. Yes, if there's one missing, you would have. I'm trying to find a good one for you. One more. I better not do that. I don't want to cause any brain explosions. My what?
screen is this file can't be sent.
Okay, just stop it. That's fine. Stop class there.
We're done?
And I gotta do the roll. Y'all need to work on 5.6 or whatever the section this is. 6 point what? 6.5. Now let me show you right quick. I'm just going to show you a little bit of 6.6 because it's not just I'm going to show it to you. And you need to look in your book because this is equations. And all they're doing is having something on the right side of the equal sign. And I'm going to just show you an example.
As long as I don't have to do inequalities, I'm okay.
Here's one right here. Yeah, that one right there. See? And what's the common denominator of 3x, x, and 1?
3x squared.
And you multiply the whole thing through by 3x squared.
So you would have been doing the number on the right side?
Mm-hmm. I'll throw this one on the board for you. You might want to put it in your notes. So some of you that want to move ahead can move ahead. You know, if you want to try some, I'll just put it on this board. 2 over 3x, and this is a simple one,
message coming in on secure
plus
channel.
1 over x is equal to 10 over 1. And this is what I do. I try to make everything a fraction. It's very important to do that. What is the common denominator?
3x squared.
So I'm going to multiply by 3x squared over 1.
I have a question. Why wouldn't it be just 3x?
Because you got 2 of them.
Okay.
I mean,
That
you're
makes
trying,
sense now.
you're
Yeah,
trying,
I get it.
yeah, that's
Because
why.
if you multiplied it by 3x, you would
It
still
wouldn't
get
work.
3x squared.
Yeah, it wouldn't work.
Okay.
You still have a fraction over here. I mean, it wouldn't work. All right, so you get 3x squared over 1, 3x squared over 1, 3x squared over 1. That's my baby step. Put that in there for you. 2 over 3x plus 1 over x equals 10 over 1. And then you cancel out and solve. So that's just a little, in other words, I don't want you worrying about 5 point, whatever section this is, 5.6, because 5.6 is a continuation, or 6.6 is a continuation of 6.5. So don't worry about it, okay? You're just finding common denominators and multiplying through. All right, let me go ahead and...
Will you be at school tomorrow?
Yeah, in the morning.
You won't be here that afternoon?
I'll be here till about 1 probably.